Hi guys, I wanted to go over density with you really quickly because I know that some people are having a little bit of a problem with it. So let's jump right in. Remember that density is how tightly packed molecules or atoms are in any object, okay? It could be something that's solid or it could be something that is liquid. So here we have two cubes and the one on the left is less dense. Because if you notice, the molecules are further apart than the one on the right. So this is more dense. And I told you to think about like a class that has 40 people in it as opposed to a class that has 10 people in it. Sorry, there's the bell. Here, let's look at another picture. This is also a good example of density. Again, the one on the left is less dense, while the one on the right is more dense. But you'll notice that on the one on the right, you also have a smaller volume. And so volume and mass both go into density. So what I want to do with you is I want to talk about how we can do some math problems with this and how we can use the formula. So let's talk about the formula for density. Density is equal to mass divided by volume. And a really easy way to remember this is to think of a heart. And then the heart gets cut in half, okay? So if you notice here, you have an M on top and then a V on the bottom for mass and volume. Now in terms of units, for mass, it is always going to be grams, or it could also be kilograms, okay? For volume, it can be centimeters cubed, okay, or it could be milliliters. And so whenever I have centimeters cubed, it's going to be because the object is a solid. Now that cube, that little 3, is not going to bother me. I do not have to do anything with that. That's just the unit and we just leave it alone. It's centimeters cubed. Think of a 3D object, okay? For milliliters, anytime I have milliliters, it's going to be a liquid. Okay, and that's also not going to bother me. I just have to remember these because I'm going to need them for my answer later on. So let's do some practice. Shlomo found a cube in the supply cabinet that has a mass of 36 grams and a volume of 12 centimeters cubed. What is the density of the cube? So here I'm going to write down my formula. Density is equal to mass divided by volume. And then I'm going to write it again, but this time I'm going to substitute in my numbers. So I'm going to have 36 grams is my mass divided by 12 centimeters cubed. Now notice how I have centimeters cubed right here because it is a solid. We're talking about a solid cube. So I take my calculator and I divide 36 divided by 12, and my answer is 3. So I have 3 grams per centimeter cubed is my answer, okay? This is my answer right here. Now, do not forget your unit, okay? And remember that this 3, I'm not going to do anything with it. It's just the unit, okay? Notice how I have my mass on top and my volume at the bottom. Be careful with those. Do not switch them around. Remember the pizza, right? If I have a pizza that's sliced into 10 pieces and I'm dividing it amongst 5 people, that's a big difference than having a pizza that's 5 slices dividing that among 10 people, right? They're going to get a different amount of pizza. So please do not switch up your numbers here. Let's do one more with a liquid. Here is your liquid example. One of the layers in Shlomo's density column has a mass of 91 grams and a volume of 7 milliliters. Again, here's my liquid. What is the density of the liquid? So I write my formula again. Density is equal to mass divided by volume. My mass is 91 grams and my volume is 7 milliliters. So I type it into my calculator, 91 divided by 7, and my answer is 13, okay, grams per milliliter. That's my unit. I just copy over my unit, and here is my answer, okay? Let's get into what you are going to be doing today. There has been a crime. Dun, dun, dun. Not really. We're just pretending. Okay, this is a fake incident crime report. Do not worry, okay? So we're going to pretend that there was a crime, and here is the police report for the crime. What has happened here is someone broke into school and stole some stuff from the cabinet, and the perpetrator left behind a tiny piece of metal, and we're going to match the density of that metal that was found in the classroom with something that some suspects have in their possession, some metal pipes that they have in their possession. So what I need you to do here is you're going to read this whole thing, and it has the crime report here, especially down here at the bottom. It tells you exactly what happened and what the police report says. Now, we have the piece of metal that was found, the evidence that was found in the classroom, has a mass of 615 grams and a volume of 75 centimeters cubed. So you're going to need to find the density of the piece of metal that was found in the classroom. Then you have the 3 pieces of pipe that the suspects had in their possession. So our first suspect is Joe E. Plummer, and you can read about his history right here, and you can read about why we suspect him. Now, the piece of pipe that was in his possession is right here. This is density problem number 2. You have your grams, and you have your centimeters cubed for your mass and your volume, so go ahead and find the density. Then here's our second perpetrator, same thing. You can read all about him and then find the density of the pipe that was found in his possession. You have your mass and you have your volume. And our last suspect right here, her history, and then the pipe that was found in her possession. You have the mass there and you have the volume there so that you can find the density. So how is this going to help us? Well, whoever has the pipe whose density matches the metal, the density of the metal that was found in the classroom, bam, that is our perpetrator, right? Just like with Archimedes and how he was trying to figure out if the king's crowns were really made of gold. He found the density of the crowns, and if they matched the density of gold, then he knew that the crowns were actually made of gold. Here is your work that you're going to fill in. So this is density problem number 1 right here, number 2, number 3, and number 4. You are going to fill in the mass that you got from problem number 1 and the volume, and then here is your answer. You're going to put in your answer. And then same thing, you're going to fill in the mass and the volume, and then get your answer for density problem number 2, and then so on with problem number 3 and problem number 4, and then you're going to match the density. One of these is going to match this density, and that's how we know who the guilty person is. Here is where you are going to explain your reasoning. Which suspect do you believe committed the crime? Right here, you're going to tell me the name of the person. Okay? And then you're going to explain to me what evidence do you have to support this claim. Here you are going to give me the answer, in other words, the density. Okay? And then here, explain how the evidence supports the claim. Here I'm telling you exactly what to do here. For this one, for letter C, you are going to explain to me that if the density of the pipe that suspect X has matches the density of the piece of metal that was found in the classroom, then that means they are the same metal, and that is why the person is guilty. I basically just gave you the answer to that one. You just have to fill in who it was and what the density was. Okay? Let me know if you have any questions, and I'll see you guys at our next meeting. Bye.